So you can only really use this, and you need to manipulate this through addition and subtraction of vectors to make this statement true. However, it's not like ordinary proofs where you start off and say, well, left-hand side equals this, and it turns into the right-hand side. They don't always work that way. Okay? It's more a series of statements that you can follow the reasoning. And so the simplest way for me here would be to say, okay, so if we look at, we want BD, right? And so if BD, I know, is half of BC. And so I can say, this vector here, how would I get that vector there? That vector there is this vector plus that vector. So I can say CA plus AB will equal BC. Now let's turn that into what we know. If we know AC is vector A, yep. Direction is important because CA.
So you just did CA and AB to BC when it should be CB. From the top. You go from the top to the bottom and then you're pointing. So with the diagram,
Yep.
you went CA to AB, which leads you to the bottom.
Yep.
But then you're saying it's BC, which is going up.
Oh, sorry, Goose. It is. Yep. So BA plus A is absolutely, sorry. And so let's now rewrite that as this. Okay? So BA, I know the vector AB is B. Alright? So that's negative B plus vector A equals vector BC. Cool with that? Now, this idea of commutativity is really important because, again, negative B plus A is the same as A minus B. Cool? And so if A minus B equals vector BC, I know from here that vector B, which should I say, vector CD plus vector DB, CD plus vector DB equals vector CB. And alternatively, I can flip that and I can say vector BD plus vector DC equals vector BC. Cool? And I know that vector BD, because it's the midpoint, is also equal to vector DC. So I can now, using this deduction here, I can then say, well, that means if vector BC is both of these together and both of these are the same, that means I can replace A minus B is 2 of vector BC. So I mean BD. Cool. And then by process of deduction, vector BD, not deduction, just algebraically, I mean. Yeah, so that's not hard. That's really logical stuff. But explaining it it's meticulous. There's so many opportunities for those stuff ups that I just did. There's so many opportunities. And so little side bits that I would recommend that you do is, obviously, you're drawing a diagram, but scribble. I know that sounds like a weird thing, but scribble on your diagram. Don't, because me just looking and explaining, I personally flip them all the time. I did that with every question that I have. Whereas if you track, I know it sounds really, really basic, but if you track, you're less likely to make that mistake. Maybe that's not part of your personality type, it's certainly part of mine, and I suspect it would be for you guys as well. Draw your diagram, scribble, and if you write what you know and what you want to prove, then you can start actually using that to get to there. The other little bit is once you've proven something, you can then use that answer to continue proving because you've already done the hard work in the previous question. So the next bit that I'm going to ask you is show that vector AD equals half A plus D.